Alright guys, so this is going to start the series on gearbox design. So before we start jumping into designing a gearbox in CAD, I wanted to talk about some of the, how do you decide things about a gearbox. So I have open right now the JVN design calculator. I like to use it a lot to at least get a rough number, and a lot of my final numbers come from it actually. But we're going to talk about making some gearboxes for the drivetrain we just built. Currently we have some that I had designed in place, at least in mine. You don't have that CAD unless you went and found it. But we're going to design some now, and we'll put them into the chassis once we have them designed. So the first thing to consider is what speed do you want to go. So I'm thinking for this chassis we'll go with like a, I don't know, maybe a 15 to 1, no, not a 15 to 1, but a 15 feet per second speed. So let's see what we have. The first thing is I'm going to show you how you can add motors into the JVN calculator, because you can see over here we have the Falcon 500 page pulled up on Vex, but if I go to my motor drop down in JVN, at least in the 2017 version that I have on my computer, there is no Falcon. So we can scroll over here to the data sheet, and you can see that it has motor specifications and everything here, and so we're just going to add in a Falcon, and then Vex gives us all of the information we need right here. So free speed 6380, which is ridiculous. Like, you see a sim is 5330, and we're putting another 1,000 on top of it. It's ridiculous, you guys. Stall torque 4.69, and then we like doubled the stall torque. Anyway, I love the Falcon. Stall current 257 amps. Free current 1.5 amps. So now we have that option. We can get back over here to our one-speed drive. That's worth noting. He has a bunch of different tabs in the spreadsheet for different types of mechanisms and figuring out gear ratios for different mechanisms, but we're going to do a custom one-speed drive. This spreadsheet is awesome, and I suggest exploring it and knowing what you can do with it. But we're just going to select the Falcon we just added. Perfect, all of our stuff got imported. Number of gearboxes in the drivetrain, we're just going to stick with the standard 2. Motors per gearbox, we'll stick with the standard 2 as well. Robot weight, we're going to set this to 150. Because that's a heavy robot. That's assuming you're at the 125 plus bumpers and battery and everything else. It's heavy. Wheel diameter. Currently in CAD we have 6-inch wheels, and then we can see if we just direct drove it, no gear ratio, nothing, we would be moving at 167 feet per second, and we would be drawing 847 amps. That's ridiculous. A motor should draw no more than 40 amps during a match. It's okay if it's pushing current draw is a little higher than that. You can compensate for that in code. You just want to get you want to get your feet per second right, and you want to make sure this isn't ridiculous, if that makes sense. So what happens if we do real fast? I'm going to pull up the gears page just so I know. Pretty much for pinions, so we can look. Our options on Falcon pinions are 8, 9, 10, 11, 12, 13, 14, so anywhere between 8 and 14. And then if we're wanting to do this in a single reduction, which is the simplest type of gearbox, which is what we'll start off with, we'll need to, let's look here. No, that's, see, we need 20 dp half-inch X. So we have 18, we have a bunch of these. So let's say we start off with a 14 tooth pinion gear, so driving gear on the motor, and then we drive, let's see, what's the biggest gear we can get? An 84 tooth. 84 tooth gear. Alright, so that puts our drivetrain free speed at about 30 feet per second, which is kind of ridiculous, right? So that means that we can do two things. We can make this gear bigger to slow it down, but that's not an option, as we can see. Or we can make this gear smaller. So what happens if we take this down to a 12? That means that our drivetrain will be running at about 20 feet per second. This is actually what we ended up with this year on our robot, which is kind of ridiculously fast. If you've seen our robot drive at full power, which it didn't in competition, but if you've seen it drive at full power, it's actually insane. But the Falcons have enough power that we can just encode, say, limit us to 70% voltage. But let's see what happens if we take this down to like a 9. It drops it down to a more reasonable number, right? That's around that 14 feet per second that I was talking about, drivetrain adjusted speed. That's a lot better than that 820 as we were seeing, right? And then, like for example, this year we ran lighter, so maybe we were actually about 120 pounds. That works. This is the actual gearbox ratio I wanted this year, but we ended up having to use a 12-tooth pinion. Even more, this is good because it gives us good torque with the Falcons, but good speed as well. And so I think this is the gearbox we're going to end up designing in this series. So thanks for watching this kind of setup video. We'll get back to CAD in the next video.